This lesson is inscribed angles. We're going to solve problems involving inscribed angles and their intercepted arcs. So let's find out what an inscribed angle actually is. An inscribed angle is an angle whose vertex lies on a circle and whose sides are chords of the circle, or one side might be tangent to the circle. But the main thing is the vertex is on the circle. So here we have angle ABC, where point B is on the circle. So this is an inscribed angle. Central angles have the vertex at the center of the circle, but inscribed angles have the vertex on the circle. So is angle 1 an inscribed angle? Well, the vertex is not on the circle, so that's a no. Is angle 2 an inscribed angle? The vertex is on the circle, so that's a yes. What about angle 3? The vertex is the center of the circle. This is a central angle, not an inscribed angle. And what about angle 4? Well, the vertex is on the circle, so yes, it's an inscribed angle. So an inscribed angle is an angle in a circle where the vertex is on the circle. An angle intercepts an arc if and only if each of the following conditions hold. We've already talked about central angles and their intercepted arcs. Now we're going to talk about the intercepted arcs of inscribed angles. So first of all, the endpoints of the arc have to lie on the circle, or have to lie on the angle. All points of the arc except the endpoints are in the interior of the angle, and each side of the angle contains an endpoint of the arc. So here we have inscribed angle ABC that intercepts arc CDA. Notice that the endpoints of the arc CDA are C and A, and both of those are on angle ABC. All points of the arc except the endpoints are in the interior of the angle. So imagine if you extended the angle further, then all of these points are on the interior of the angle. And then each side of the angle contains the endpoint of the arc. So this side of the angle contains point A, and this side contains point C, which are the endpoints of arc CDA. So that makes an intercepted arc of the inscribed angle. So we can say that arc ADC, or arc CDA, either is correct, is the intercepted arc of angle ABC. Now we have a couple of theorems involving inscribed angles. The main one we will use is that the measure of the inscribed angle is equal to half the measure of the intercepted arc. So in this picture, the 55-degree angle is inscribed because the vertex is on the circle, and the intercepted arc is arc YZ. The inscribed angle is half of the arc because 55 degrees is half of 110 degrees. So the inscribed angle is half the measure of the intercepted arc. Or if you think of it the other way around, the arc measure is 2 times the inscribed angle measure. Also, if two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Now that sounds a little bit strange, but let me show you what that means. Suppose I had a circle with an intercepted or an inscribed angle that intercepts this arc and another inscribed angle that intercepts the same arc. Both of these angles intercept that arc. Now if this arc measure is 60 degrees. Since they both intercept the same arc, this angle is half of the arc, so it's 30 degrees. And this angle is also half of the arc, so it's 30 degrees. They are the same. That's what this theorem says. When two inscribed angles intercept the same arc, then they're congruent. Let's find x and y in this figure. Well, I have several inscribed angles here. Angle y, or the angle that is y degrees, intercepts arc AC. Angle ABC of 50 degrees also intercepts arc AC. And the x degree angle also intercepts arc AC. So since all three of these angles intercept the same arc, then they're all congruent. So I know immediately that x equals 50 degrees and y equals 50 degrees. Now if I want to prove that a little bit more so, I mean this is my final answer, but just to verify that, if angle ABC is an inscribed angle, it's half of the measure of the intercepted arc. So the arc is twice the angle measure. So 2 times 50 is 100 degrees. So this arc is 100 degrees. Well, this angle AEC intercepts this arc. The inscribed angle is half of the arc. So I can say that x is half of 100. It's half of 100, which is 50 degrees. The angle AFC is an inscribed angle that intercepts this same arc. The inscribed angle is half of the arc, so y is also half of 100, which is also 50 degrees. So you might notice that, hey, they all intercept the same arc, so they're congruent. Or you might need that extra step where you work your way through. The inscribed angle is 50, the arc is twice that, and then the arc is 100, the inscribed angle is half of that. How about this one? Here, I can see x here, angle AED. That's an inscribed angle that intercepts the 40-degree arc. So that means that x is half of 40. So x is 20 degrees. The inscribed angle is half of the arc. That's a 20-degree angle. That didn't really show up good. Let's see. If I say 20 degrees and then give me a little arrow. There we go. The inscribed angle is half of the arc measure. And I have another inscribed angle right here at 50 degrees. And it intercepts this arc, arc AC. The inscribed angle is half of the arc. So the arc is 2 times the inscribed angle. 2 times 50 degrees is 100 degrees. Y is a part of that. I can see here that the arc that's 40 degrees plus y is a total of 100 degrees. Subtract 40 from each side, and y is 60. So sometimes you need to do a little bit of arc addition. The parts of the arc add up to the whole arc. But in all of this, an inscribed angle is half of the measure of the intercepted arc. Another rule we have is that an angle inscribed in a semicircle is a right angle. And that actually makes perfect sense because this angle is an inscribed angle because the vertex is on the circle. If it intercepts a semicircle, well, a semicircle is half of the circle, which is 180 degrees. The inscribed angle is half the arc, and half of 180 is 90 degrees. So if an inscribed angle intercepts a semicircle, then it's a right angle. And then you have right triangles here. You might be doing the Pythagorean theorem if you know certain side lengths. So be prepared for that anytime you end up with a right triangle. Another rule we have is that if you have an inscribed quadrilateral, then the opposite angles are supplementary. So angle DAB right there and angle DCB add up to 180, and measure of angle ADC plus the measure of angle ABC is also equal to 180. When it's a quadrilateral, opposite angles are supplementary. So maybe this is 100 degrees, and its opposite angle has to be 80 degrees since they add up to 180. And maybe this one is 95 degrees, which means angle B has to be 85 degrees since those add up to 180. Anytime a quadrilateral is inscribed in a circle, opposite angles are supplementary. So just remember, the inscribed angle has a vertex on the circle, and its measure is half of the intercepted arc.